Let's solve this problem using factoring. So step one, when we do this, we want to make sure that our equation is in standard form and make sure that one side is equal to 0. So we know that standard form is ax squared plus bx plus c, and we want to have it equal 0. We can see that our terms are out of order, so let's go ahead and fix them. I can move the terms on one side of the equation as long as I keep the sign to their left with them. So now I've met step number 1. Let's look at step number 2. It says factor the non-zero side of the equation. The first thing I want to do is check for the greatest common factor. 12, 7, and 12 do not have a greatest common factor. So next, I count the number of terms. I have 3 terms. 3 terms means that I'm going to factor a trinomial. The method I'm showing in the notes is bottoms up method or factoring with an X factor method. So in order to do this method, I want to say what A, B, and C are. And we know that when I'm in standard form, A is the number in front of the X squared. And we need to make sure we take the sign with it. That's a positive 12. B is the number in front of the X. And C is the number by itself. And notice I take negative 12 because there's a minus in front of it. Next, I'm going to multiply A times C. And I get negative 144. I put this on the top. And then this is AC. And then I put the B in the bottom. I want factor pairs that multiply to be AC and that add to be B. So my factor pairs for negative 144, if I don't know them or I'm not comfortable getting them by just making a factor rainbow or listing them, I can use my calculator. To use your calculator, go to your grapher, y equals, and enter in AC. So for me, it's negative 144. And then divide, and then your X. Hit second graph, and it will give you a table. This will give you all your factor pairs. So I'm looking for a factor pair that adds up to 7. And I can see that if I go this direction, I can see I'm going to have negative numbers. So let's try the other direction. So negative 6 plus 24 would be 18. I don't look at the ones that are decimals. Negative 8 plus 18, that would be 10. Negative 9 plus 16, that would be 7. So do you see how I scroll down or up trying to find the factor pair, whole numbers that multiply to be negative 144, which will automatically happen since we entered it in as y equals negative 144 divided by x. Now all we're having to do is check for which ones add to be 7. So I have 16 and negative 9. And it does not matter the order you write them in the X, as long as they're on the sides. Next, I want to divide by my A on both sides. And I want to simplify each fraction. Now, if you're having problems simplifying fractions, what you're going to do is you're going to enter in the fraction 16 divided by 12. And then you're going to hit math 1, enter. And it says that's equal to 4/3. So math 1, enter can really help you. Let's do another one. So negative 9/12. Math 1, enter is equal to negative 3/4. I take these two numbers and I put them in as my second term. Now 4/3 is positive and minus 3/4 because it's negative. The variable alone goes as a first term always. Now here's the part that's the bottoms up. Whatever denominator is in your second term, it needs to come up to the front. So it becomes 3x plus 4. And next, I want to take my 4 and put it in front of my x, and I'll have 4x minus 3. So now I've factored my trinomial. So we can move on to step 3. Step 3 says apply the zero product property. What we're going to do here is we're going to set each factor equal to 0. So I say 3x plus 4 is equal to 0, and 4x minus 3 is equal to 0. And I solve each equation. And I get x is equal to negative 4/3 and x is equal to 3/4. Our last step is just to check our answers, and it says this could be optional. But if you want to make sure you're right, you're going to always want to check your answer. I checked both my solutions, and both made true statements, so they are correct. Our next problem, we want to use the square root method. Now, if it didn't tell us which method to use, I would know to use this because it's in vertex form. And I could also note that there is no x term. That's an easy way to see that if you don't have an x term, you can use the square root method. The previous problem, you can see that I had an x term, right? You can't use the square root method when you have an x term. So let's solve using the square root method for this problem. Step number 1, isolate the squared variable term. What we're trying to do is get this whole expression, whatever is squared, whether it be a variable or an expression with a variable, we want to get it alone, isolated. So I'm going to add or subtract first. Just like when I'm trying to isolate or solve for a variable. And then I'm going to use multiplication or division so that we can isolate the variable expression by itself. Our next step is to undo the square using the square root property. So we're going to take the square root of both sides. When I take the square root of a square, I get the radicand itself without. Now the other side is going to be the square root of a number. So we have to remember that when we take the square root of a number, it could be plus or it could be minus. This is the big mistake people make. Let me say it one more time. The side with the number has to have a plus or a minus in front of it. We're going to simplify our radical. Now, to simplify a radical, we can write the prime factors. So we can make a tree if we need it. And we can find the prime factors. So I have a 2 times 2 times 5. I also have a negative 1 here. Now, when it's a square root, any pair that I have can come out of the radical. And if I take the square root of negative 1, this is going to be I, because we know that the square root of negative 1 is equal to I. It's an imaginary number. So I'll end up with 4 plus 3x is equal to plus or minus 2 square root of 5i. And notice the I is not under the radical sign. We're not done yet. We have to get the x by itself. Remember, that's what our goal is. So I'm going to subtract 4 from both sides. And then I'm going to divide by 3. So I'll end up with x is equal to plus or minus 2 square root of 5i minus 4 divided by 3. Now, typically we put the real number first. So I'm going to put negative 4/3 first. And then I'm going to put plus or minus 2/3 square root of 5i next. And you may notice in our book, it likes to put the I after the number before the radical. And as always, if we want to, we can check our answer to see if we're right by putting it back into our equation and verifying that this will make a true statement. Our next problem, we're going to solve by completing the square. When you complete the square, there are a few steps that you need to use. And this is not hard, so if it's something new, just practice it a few times. The first step I'm going to do is I always look at the coefficient in front of x squared. So our a, I want a to be positive, and I want it to be a positive 1. So we have a -3. So I'm going to divide everything by -3 on both sides of my equation. And I'll end up with x squared minus 2x is equal to -2/3. My next step is to get the constant alone. So if my c had been on the other side, I would have moved it over to this side, but our problem already came with the c isolated on the right. So I wanted to have ax squared plus bx on one side of the equation all by itself. Now, here's where we're going to complete the square. What we're going to do is we're going to add b over 2 squared to both sides. So you can see that our b is -2. So b over 2 squared would be -2 divided by 2 squared. So this would be -1 squared, which is 1. So I'm going to add 1 to both sides of the equation. On my left side of my equation, you can see I rearranged it so it's nice and neat so that you can see how this works. I put my squared term first, my bx in the middle, and then my c next. It always will be a perfect square. So if you were to factor this, you would get x and 1 and 1 and minus and minus. And you could rewrite this as x minus 1 squared. It will always be a perfect square when you add b over 2 squared to both sides. Now on the right side, if you're comfortable adding fractions, you can see this is 1/3. If you're not comfortable adding fractions, then get your calculator out, type it in, and then hit math 1, and it will give you the fraction. Now we can use our square root property because we don't have any x terms floating around. So we'll take the square root of both sides. When you take the square root of a squared expression or variable, you end up getting the squared expression or the variable alone. On the other side of the equation, when you take the square root of a number, you must put a plus or minus in front of it. That's the gotcha that people forget. So make sure you put that plus or minus in front of the number. And now we want to keep going and solve for x. We have a -1 with it, so we're going to add 1 to both sides. So I get x is equal to 1 plus or minus the square root of 1/3. Now a little note, you may see it in a different form. You may see some people will take the square root of 1/3 and write it as the square root of 1 over the square root of 3, and they'll rationalize the denominator. When we rationalize the denominator, we multiply the denominator times itself, and we'd end up with square root of 3 over 3. So we could rewrite this as 1 plus or minus the square root of 3 over 3 if we would like our denominator rationalized. The next problem asks us to find the discriminant and state the nature of the solutions. Before we start these, we have to make sure that we are equal to 0. So if we're not equal to 0, go ahead and move that other side so that we are equal to 0 and we are in standard form, where we have ax squared plus bx plus c is equal to 0. Now we can quickly label a is equal to 3, the number, it's a coefficient in front of x squared. B is equal to 5, the coefficient in front of x. And c is equal to -9. It's the constant by itself. To find the discriminant, we have to know where it is in the quadratic formula. So our quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the radicand, the stuff under the radical. So our discriminant is b squared minus 4ac always. So now let's go ahead and fill in those numbers for our variables. We'll evaluate when b is 5, when a is 3, and when c is -9. So let's go ahead and simplify that. Discriminant is 133, and that means it's a positive. So when our discriminant is greater than 0, we're going to have 2 real solutions. Our next problem, it's already equal to 0. So we're trying to figure out what a B, and C are. A is the coefficient in front of x squared, so negative 6. B, x. There is no x term, so our B is 0, and our C is a constant by itself, negative 2. We know that our discriminant is always B squared minus 4AC, always. So let's evaluate it for these values. So B is 0, A is negative 6, and C is negative 2. So we end up with negative 48. This means we're going to have no real roots, and we're going to have 2 complex roots. Next, we're going to use the quadratic formula to solve our quadratic. First thing we want to do is we want to get ax squared plus bx plus c equal to 0. So if we're not equal to 0, be sure to move the number to the other side. Next, we want to make sure that we're actually in standard form. So rearrange those terms on one side so that you have the ax squared plus bx plus c format. Now we can actually determine what a is, what b is, and what c is. A is the number in front of the x squared. That coefficient is negative 4. B is the number in front of the x. And c is the number, the constant by itself. Now we need to memorize the quadratic formula, and there are several ways to do it. One is a mnemonic device with a story, and it goes like this. A negative boy couldn't make up his mind whether he should go to this really radical party. Because he was square, he missed out on meeting 4 awesome chicks. And the party was all over by 2 a.m. Perhaps that might help you memorize it. Or maybe you can Google and learn a song. Some people sing Pop Goes the Weasel or the Flintstone song to help them memorize it. Once you have it memorized, you just need to evaluate it for your A, your B, and your C. I'm going to share with you that same tip I've shared before. Whenever I evaluate something, I use parentheses wherever there's a variable, and then I go ahead and put the number in. That way I don't mess up the signs. Typically, I simplify the radicand first. So 9 plus 128 would be square root of 137. Now, if you're going to use this in your calculator, be very careful. This is where people make the most common mistake. When you're entering in your calculator, you'll have to enter it in twice. So the first one would be 3 plus the square root of 137. Now, you can do it 2 different ways. You can hit enter and then divide by the denominator. And I get negative 1.84. Or, let's do it again. Another way you can do it is you can say 3 plus, and then square root of 137. And then divide by negative 8 in one line. But if you do this, you must enter a parentheses before and after when you're indicating the numerator, and then divide by your denominator. And you'll get the same thing. Be very careful. I recommend hitting the enter button first and doing it the first way, where you just enter and now divide by the denominator. Too many people make a mistake when they're entering it in one line. Okay, let's do the second one. So 3 minus the square root of 137. Hit enter, and then divide by negative 8. And I get 1.09. And when you're using that calculator, remember that these are actually approximations, because really we know that this extends farther. I just rounded it to 2 decimal places. And we use this little approximation symbol. It's a little wave, and it means approximately. Next problem asks us to find any possible solutions. We know that the word solutions is another name, code word for our x-intercepts. So our x-intercepts are where the function crosses the x-axis. So in our case, it intersects at one place. but it might be 0, it might be 2 places, or it might be 1. So our x-intercept is 4. So our possible solution is x is equal to 4. Next, it asks us whether the discriminant is negative, positive, or 0. We know that the discriminant, the radicand, b squared minus 4ac, if it's greater than 0, positive, it will have 2 real roots. If it's equal to 0, it will have 1 real root. And if it's less than 0, it'll have 0 real roots. So in our case, we have 1 real root. And since we have 1 real root, we know that our discriminant was equal to 0. Next, we're going to practice finding the solutions in our calculator. To do this, we have to have y equals, or we have to have an equal 0, or y equals 0. So if we have a number that's not 0, we need to move it so that it is 0 on that side. So let's add 2.9 to both sides. Now, we can enter this into our equation. And the reason this works, to put it in our grapher, is that we know that the solutions for a quadratic are the x-intercepts, and the x-intercepts occur when y is equal to 0. We'll enter in negative 1.9 x squared plus 4.6 x plus 2.9. Once I have that entered, I'm going to enter a second equation. I'm going to enter in y2 is equal to 0. This way I can use the intersect method, and I hit second trace 5. You can see I have 2 zeros. I'm going to go ahead and hit enter 3 times. 1, 2, 3, and it will give me one of my zeros. One of my zeros is at negative 0.5191239. Our problem asks us to round to 4 decimals. So I'm going to say negative 0.5191. Now I have my first zero. To find my other zero, I'm going to repeat the process. I'll say second trace 5. But before I hit enter 3 times, I want to move with my right or my left arrow so that I'm closer to my zero that I'm looking for. And then I'm going to hit enter, 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 and it will find that one. So my next zero is 2.9402. And now I found both zeros. Our next problem is a word problem. VJ has decided to go bungee jumping with his friends on his 30th birthday. The bridge from which he is jumping is 250 feet above the surface of the river. The height in feet, h, of VJ as he jumps and then dives into the water can be described by the function h of t, where t is time in seconds. So the first thing I do on a word problem typically is I kind of sketch what I have. So VJ is going to jump. When he jumps, it's going to push him down and then it's going to pull him back up. Right? So we know it's going to be heading down and then back up. So it's going to make a nice little parabolic shape. They give us the function as h of t is equal to negative 16t squared plus 250. Part A says find the height of VJ after 2.5 seconds. So this is simply, we're going to evaluate our function, which is at 2.5. So at 2.5 seconds, he'll be 150 feet above the water. B asks when he'll be 25 feet above the ground. I think actually they really mean above the water surface. So let's take our function now, and we know that h of t, this is equal to the height above the water. So we're going to say this is going to be 25. Okay, so we have a quadratic here. We've learned several methods. We could use the quadratic formula. We could use the square root property. We know that we can use the square root property because I don't have any kind of t term. Okay, so let's just go ahead and do that. So we'll say get the square by itself. Once I have the squared term or expression by itself, I can take the square root of both sides. Remember to put a plus or minus in front of the number. Now, it says round to 2 decimal places, so we're going to need to put this in our calculator. Now, this is a word problem, so it has some application issues you have to talk about. So first of all, we know that time can never be negative. So we don't want to consider the negative 3.75. Instead, we'll just look at the positive 3.75. So it's going to be 3.75 seconds. And we always want to remember to put our units on these kind of word problems so we know what we're talking about. C asks us, when does VJ reach the surface of the water? So this is easy if we remember that the definition of H is it's the height above the water. So H of T is equal to 0 when he reaches the surface of the water. So we'll once again use the square root property, and we'll get plus or minus 3.953. But once again, we realize that time cannot be negative, so we'll only consider the positive root, 3.953 seconds.